Good morning, everyone. I'm Shreya from Kale University. Today we are learning an interesting topic called convolutional neural networks. We are learning these all topics how why CNN, applications of CNN, and what CNN does, and layers of CNN, and complete CNN architecture and limitations of CNN. Basically, a CNN, a convolutional neural network, is a type of artificial neural network which is used in image recognition and processing. And the CNN are powerful image processing methods in artificial intelligence that use deep learning, which perform both generative and descriptive tasks. Now we are learning about CNN applications, which are image classification, object detection, image processing, neural style transfer, face detection, speech recognition. And we are learning what a CNN does. Basically, CNN is we know that CNN helps us to recognize an image. If we give the input as a pixel input image, then it will be converted into the input layer, and then it will go through the hidden layers, which contains like convolutional layer, pooling layer, and all. And then it classifies the input image and then gives us the output, whether what an image input image information. It does the task similar to the human being, and it maintains the spatial information about the input image we are giving, and it also identifies this pattern. Now we are discussing about layers of CNN. The first layer, which is input image which we give, and then the input image. The next layer will be consisting of convolutional layer, and then pooling, and then fully connected, and the output layer. In this layers like input and classification and convolution and pooling, feature extraction will be done, and this fully connected layer and the output layer will classify the image. We'll discuss this topics later. Now we'll learn deeper about CNN, where CNN is composed of multiple layers of artificial neurons. Uh, this artificial neurons, at each layer, it calculates the weighted sum of the multiple inputs and outputs, and each activation value will be sent to the next layer. I mean, it will be passed to the next layers, where first layer, which basically extract the basic features of the image, such as horizontal edges and the edges of the input image, and then that output will be sent to the next layer, where the next layer will take the complex features than the first layers, and then it will be like corners or combinational edges, and then it will be sent to the next layer. So as we move deeper to the network layers, then it can identify even more complex features, such as objects and faces of the input image we give. So based on the activation map of the final convolutional layer, the classification layer outputs a set of confidence score, like 0 to 1, that specify how likely the images belong to a class. If the image we give as cat, then the layers like output will be consisting of cats, dogs, and some in like some animal features. So each of the cat, dog, etc. will be given the probability like 0 to 1. Then which has the highest value of the confidence score, then it is belonging to the class. Now we'll discuss about the layers of the CNN, where first, after giving the input, and it will convert into convolutional layer first, where this convolutional layer are the major building blocks is used in CNN. As a convolutionally simple application of a filter, which is applied to the input image, like filter or kernel, which is applied to the input image, that results in an activation, that results in an output of the particular layer. Repeated applications of the same input of the same filter to an input results in map of activations called a feature map, indicating the location and strength of a detector feature in an output, such as an image. Like in convolutional layer, what happens is basically the for the input image, the filter is added, like a filter or kernel is added to it, and we'll get a convolutional matrix as an output, and which is sent to the next layer as pooling layer. The innovation of convolutional neural network is the ability to automatically learn a large number of filters in parallel specific to a training dataset under the constraints of a predictive model problem, such as image classification. The result is highly specific features that can be detected anywhere on an input image. We can see the diagram here, which is input image, which is converted into matrix. and then it is taking and then it is applying the kernel or filter, and then it is giving the output which is sent to the next pooling layer. We'll discuss about the next layer called pooling layer, which is similar to the convolutional layer. This pooling layer is basically responsible for reducing the spatial size of the convolved future. That is uh, that is if we get an output in the convolutional layer, in so what the output of the convolutional layer is maximum is reduced in this pooling layer. So that is use this. So this is basically used to decrease the computational power required to process the data by reducing the dimensions. So it basically reduces the dimensions, which is more helpful for us to classify the image. There are basically there are two types of pooling, which are average pooling and max pooling. Uh, Max pooling, which is used to find the maximum value of a pixel from a portion of image covered by the kernel. Max pooling also performs as a noise suppressant, that is which reduces the noise in the image. It discards the noisy activations altogether and also performs denoising along with the dimensionality reduction. And next we come to average pooling. Average pooling returns the average of all the values from the portion of the image covered by the kernel. Average pooling simply performs dimensionality reduction as a noise suppressing mechanism. Hence we can say max pooling performs a lot better than average pooling. So we can see it in this image where we have a matrix which is converted into max pooling, where it is taking the maximum values of the portion of the image, and the average pooling where it is taking the average of the portion of image of an input that is getting to the pooling layer. And then we'll discuss about limitations of CNN, where CNN at a point can be slower due to the max pooling, where this process can be slower due to max pooling, where max pooling need to perform tens of thousands of iterations on each feature map. So it may be uh, it may slow down at particular layers. So if the CNN has several layers, then the training process takes a lot of time if the computational computer doesn't consist of a good GPU. If the graphic processing unit is not good, so this CNN might take might take lot of time to process. So a convolutional neural network requires a large data set to process and train the neural network, which is basically the limitation, as some of the input image cannot contain the large data set. Thank you.